Hi everyone, this video is going to be on trig addition formula or compound angle formulas for trigonometric functions. So what we're talking about here is where we have sine A plus B, and we're going to develop the formulas really quickly for that. So first thing to look at is, does sine of 30 plus 60 equal sine 30 plus sine 60? You know, like normally you'd expand brackets and you'd expect to see it like that. However, we quickly see that sine of 30 and sine of 60, the right hand side of this equation, is not the same as sine of 90. So this does not work, unfortunately. It'd be nice if it did, but it doesn't. So we need another way of doing this. So we can write it in terms of sine A cos A, sine B and cos B. So although the little proof here is for acute angles, it does work. You don't have to know how to do this proof. Okay, so if we start with a rectangle, we've got angle B, and then we're going to rotate that rectangle around through an angle A. And what I want to get is an expression here for sine of A plus B. So sine of A plus B is just opposite over hypotenuse. So if that hypotenuse there is 1, we're really looking for the length of h. That's sine of A plus B. So let's look at how we can get h. We've got a few angles going in here. This one here is 90 minus A. That angle there is 90 minus A, hence that angle at the top is A. So now we can look at some right angled triangles that we do have. So we can split the length of h up into two different lengths, the purple length and the red length. Okay, and then we're going to work out both of those. So the red length is the same as that one. So let's get the length of TQ. So from that triangle there, sine of A is equal to TQ over A. So therefore TQ is A sine A. So that's half of our puzzle formed. Now looking at that right angle triangle at the top there, MQR, we can say that cos of A is equal to MR over B. So MR is B cos A. So therefore that H that we're looking for is A sine A, that's T to Q, or M to M, plus M to R, which is B cos A. Okay, we can do the same thing for cos of B and sine of B. Work out that they're just A and they're just B. So that is the height. Cos B sine A plus sine B cos A. Okay, so that is the expression for sine A plus B. It is on your formula sheet. You do not need to know the proof. We can find other relationships because we understand the basics of cos of minus B is just the exact same as cos of B. I could do this on the unit circle as well. And sine of minus B is the negative of sine B. So I've showed these relationships on the unit circle before. So if you use, and of course cos of A is the same as sine of 90 minus A. Okay, so there's a few relationships there that we can use to change these identities. So we've got the identity for cos A plus B, etc. Okay, and there's another one. Okay, so if we just make some changes in there, so replace B in the first one by negative B, then you can see in that formula there, cos of negative B is just the same as cos B, sine of negative B is negative sine B, so now we've got the formula for sine A minus B. Okay, I'm going to skip through this really quickly. There's a number of different things that you can do, and you get all the formulas. I'm really interested in how we apply the formulas. Tan of A plus B, sine of A plus B over cos of A plus B. This is a really nasty step here, dividing everything by cos A, cos B. Bit of cancelling, and we get tan A plus tan B on the top line over 1 minus tan A, tan B. If you want to pause it there, there's the proof for tan A plus B. Once again, you do not need to know this. We don't need to know how to get it anyway. Okay, so these are all on your formula sheet. Notice that here we've got A plus B, and over here, sorry, the plus or minus here between A and B, and the plus or minus here. In the cos one, we've got plus or minus and minus plus. That just means if you go cos A plus B, it's cos A cos B minus sine A sine B. You take the top one. Same for the tan identity. Okay, so here's how we use it. What's the exact value of sine 135? Well, we could write sine of 135 as 90 plus 45. I know we could work out the exact value here like we did before, but using this identity of sine A plus B as that, we can then say sine of 90 plus 45 is sine 90 cos 45 plus cos 90 sine 45. I'm just using the identity that you've got given on your formula sheet. We know sine of 90 is equal to 1 and cos of 90 is 0. So that just gives us 1 over root 2. We can use it in proofs. So on the left-hand side here, we can expand the left-hand side, use the identities for sine x plus y and sine x minus y, show that you get some cancelling there, leaving us with the answer. So all kinds of questions you could do. Here's one more example. If we wanted to do cos 75, that's 45 plus 30. And then just put in the exact values that you know for cos 45, sine 45, cos 30 and sine 30. That gives you the exact value of cos 45. Okay, can you pause and on your handout try the questions on page 60 and write the answers down for A and B.